All right, now we're going to generalize this idea, and I'm going to say it one more time. Make sure you're tracking with me. So this one says, in this context, how many 2/3 of a cup scoops would I need to scoop in order to create 1 cup of flour? And the answer would be I need one scoop, 2/3 of a cup, and then another half, because half of 2/3 is 1/3. It's another half of a scoop, so 1.5. Notice that compared to this, it's half as many scoops. I needed 3 scoops of size 1/3 of a cup to make 1 cup. Now I need 1.5 scoops of size 2/3. Now why? Because a 2/3 of a cup is twice as big as a 1/3 of a cup. And since the scoop is twice as big, I need half as many. Half of 3 is 1.5. So in general, what are we talking about here? Suppose we have a measuring cup that contains A over B, A copies of 1 over B cups of flour. And the recipe still calls for 1 cup of flour. So here's what I would argue. Just like 2/3 is twice as big as 1/3, A over B is A times as big as 1 over B. 1 over B is just 1 copy of 1 over B. A over B is A copies of 1 over B. So A over B is A times as large as 1 over B. Since A over B is A times bigger, I'm going to need 1 over A as many. Did you catch that? So here it is in mathematical language. So if my scoop size is A over B, then I'm going to need 1 over A as many as I did of the 1 over B. Now, in the case of my previous one, I had a 2/3 here. And with a 2/3, it's twice as big. So I needed 1/2 of a 1/3 in terms of the number of scoops. So this is a general idea here. Now look how this flows out now. So 1 divided by A over B is this. You start with 1 divided by 1 over B, and you would say, well, I would need B of them to make a full cup. But with A over B, I'm going to need 1 over A as many, and 1 over A times B is B over A. So look what happens here. 1 divided by A over B becomes B over A. Whoa. Now you might have to spend some time thinking through this, pause the video, let this, I've been talking about this for decades, and so I see it so well, you're gonna have to spend some time thinking about it. So pause the video and think here. You'll also have some opportunities later to keep thinking, but do some of the thinking right now. All right, now we're gonna change things up a little bit. What if the recipe called for 3 cups of flour instead of just 1? And let's just say you only have a 1/4 cup measuring cup. How many filled 1/4 cup measuring cups, that is, how many scoops, are needed to make the requirements of the recipe? So how many 1/4 does it take to make 3 cups of flour? So 1/4, 1/4, 1/4, 1/4. 4 1/4 would give me 1 cup. Another 4 would give me 2 cups. And another 4 would give me 3 cups. It would take it would take me 12 of those scoops in order to get to 3 cups of flour. And that's what I have here. So 3 divided by 1/4. Now, how many 1/4 does it take to make 1? 4. I need to do that 3 times. Notice, 3 copies of. Now, what am I really getting at here in terms of cups of flour? 3 cups of flour is 3 copies of 1 cup of flour. So how many scoops does it take to make 1 cup of flour? 4. I need 3 times as many to get the 3 cups. I need 3 times as many to get 3 cups, so 12. We need 12 filled 1/4 measuring cups to meet the requirements. All right, so now did you see that I changed the number of cups to be 3 times as many? And if you need 3 times as many cups, you're going to need 3 times as many scoops as it took to make 1 cup of flour. So say that one more time. 1/4 of a cup 4 times would give me 1 cup of flour. Another 4 would give me 2 cups of flour. And another 4 would give me 3 cups of flour. So it was 3 sets of 4. It was 3 copies of what I needed for 1 cup of flour. And so 3 copies of 4 is 12. Now let me pause here for a minute. I've been doing this a long time with a lot of different people, from kids to in-service teachers. And I know that the thinking is a lot harder than just remembering the rule, remembering the song, or sometimes with division of fractions, the little phrase people use is keep it, change it, flip it. Just keep it, change it, flip it. But when you just keep it, change it, flip it, you don't learn why. You don't understand it. So this takes more cognitive load, is the word we use in education. It's a deeper cognitive load. It's a higher depth of knowledge, we might say. And so we have to take more time to think about it. The more you productively struggle to think through this, the more you express it, the more you talk about it, the more you write it down, the more you think about it, the more it's going to make sense. So please do that. So in general, a recipe calls for C cups of flour. You only have 1/B measuring cups. How many filled 1/B measuring cups are needed to meet the requirements? All right, so 1/B, B times gets you to 1. Another B would get you to 2. Another B times gets you to 3. You would have to keep copying that C times. So look, C divided by 1/B is really the same as C times. So I need C times as many as I needed for 1 cup of flour. Oops. I need C times as many as I needed for 1 cup of flour. How many 1/B's did it take to make 1 cup of flour? B. Now I need C times as many. C times B. So C divided by 1/B is the same as C times B. Keep it, change it, flip it. I mean, it's happening, but I hope it's happening from our thinking, not just from memorizing a routine or memorizing and mimicking a procedure. All right, spend some time thinking about that, and then when you're ready, a recipe calls for 2 cups of flour. You only have 3/4 of a cup. How many filled 3/4 cup measuring cups are needed to meet the requirements of the recipe? Will you pause the video, give this a shot, see if you can track through this line of reasoning, but make your brain think about the what's and the whys, and see if you can do it. And then resume the video and see if you're tracking as I demonstrate. So here's how I would demonstrate it. A recipe calls for 2 cups of flour. I only have a 3/4 cup measuring cup. So when I've taught this with students, here's how we usually break it down. Let's start with just 1 cup of flour. Suppose all you needed was 1 cup of flour. And let's start with 1/4 cup instead of 3/4 cup. So the first question I would ask is, how many 1/4 does it take to make 1? Well, 4. 1/4, 2/4, 3/4, 4/4. It would take 4 1/4 to make 1. Start there. Then you might think of it this way. Instead of a 1/4 cup, I have a 3/4 cup. Notice that the size of the scoop, if you will, is now 3 times as big. And if the scoop is 3 times as big, because 3/4 is 3 copies of 1/4, 3 times 1/4. So since my scoop is 3/4 as big, I'm only going to need 1/3 as many that I needed before. And then, finally, I needed not 1 cup, but 2 cups. Now, from 1 cup to 2 cup, I doubled how much flour I need. So I'm going to have to double how many scoops I'm going to need. All right, so watch the flow here. I start with what's easier to think about. It's easier to think about 1 cup of flour and a 1/4. It takes 4 scoops, 1/4, 1/4, 1/4, 1/4 to make 1. Then I make the scoop 3 times as big. And if you make the scoop 3 times as big, you're going to need 1/3 as many of the 4. And then I say I need actually 2 cups of flour. I have twice as much flour, which means I'm going to need twice as many scoops. And so it all boils down to this. If you had to just write this in an equivalent way, notice the 2, notice the times, and then 1/3 times 4 is 4/3. Did you notice how 2 divided by 3/4 turns into 2 times 4/3? Ah, there it is. That's the algorithm that we saw in that previous video. Keep the first number, change divide to multiply, and take the reciprocal. But why does it make sense? It makes sense for two reasons. First of all, if you triple the size of the scoop, how much flour is in each scoop, you're only going to need 1/3 as many scoops. And if you double how much flour you need, you're going to have to do that number of scoops double as many times, twice as many times. And so we see the thinking unfold.